Hello and welcome to the Security Industry Association webinar, Best Practices for Partnering Security and IT. I'm Ron Hawkins, Director of Industry Relations for SIA. The Security Industry Association is the leading trade association for businesses in the electronic physical security sector. We have more than 900 members, including manufacturers, integrators, service providers, dealers, distributors, and others. And we provide them with services in the areas of education and training, government relations, technical standards development, research, and networking. Also, we are the official industry sponsor of the ISE Expos and the provider of all content for the ISE West and ISE East education conferences. Our speaker today is Brandon Reich, Vice President, Security and IoT at Pivot3. Brandon is an accomplished strategy, product, and go-to-market leader with a record of driving proven results in both small entrepreneurial companies and global corporations. Brandon came to Pivot3 in 2014 from Honeywell Security Group, where he led the product marketing and global strategy functions for the commercial and enterprise technology business unit. Prior to Honeywell, Brandon spent 10 years leading a security consulting and engineering firm, advising large enterprise, critical infrastructure, and institutional clients in all aspects of physical security planning and deployment. He holds a Bachelor of Science degree in electrical engineering and an MBA with a focus on entrepreneurship from the University of Louisville. Please note that there are 4 handouts that you can download to learn more about the issues we're discussing today. They're located in the sidebar. And remember that we'll have a Q&A session at the end, so please submit your questions also in the sidebar. And to preemptively answer one question, we will email the presentation and a link to the recording to attendees this week. Now, let's find out more about one of the most important challenges in the industry today, getting the physical security and IT departments to work together. Brandon?
Okay, thank you, Ron, and thank you everyone for joining today. As Ron mentioned, my name is Brandon Reich, Vice President of Security and IoT with Pivot3. And can we bring the slides up here, Ron?
Yep, you should have it.
There we go. Okay, great. So the agenda for today. We're going to spend a little bit of time up front here talking about some of the big trends in the world of IoT, where we'll talk about what that means, physical security, and particularly video surveillance, which I'm sure is a topic that all of you on this call today are interested in. Then we're going to spend a little time talking about different IT terminology and some things that you need to know and to understand as you're dealing more and more with your IT departments. And we're going to spend a few minutes here talking about the arising partnership as well as the potential conflict that can emerge and come between our security and our IT counterparts in our organizations. We're going to talk about some of the new technologies in the IT world that are impacting the physical security world and can be utilized in physical security, what kind of impacts that might have on your business or your organization. And then we'll wrap up today on what are the ultimate best practices for ensuring that that partnership between security and IT is effective and successful. And we'll talk about some real world examples of how to make that happen. Okay, so let's start up a little bit here about what's happening in the world of physical security. I know certainly for the people on this call, this is something that you're probably very familiar with and very involved with on a day-to-day basis. What we know in general for our organizations is that the risks or the things that we are protecting against in our organizations, like our people, our property, our assets, our intellectual property, our brand in some cases, our operations, those risks for the most part really haven't changed over the last 10 or 20 years or so. However, the threats against those risks certainly have changed, and they've changed pretty substantially, as we all know. So as a result of that, many organizations are increasingly turning towards new technologies and deploying new applications or the latest and greatest technologies to help mitigate some of those threats that are out there. Now, all of this new technology is great, but what we need to understand is that this new technology is generating huge amounts of new data. And in fact, we're going to talk in just a minute about what that data is and how much of it is actually out there. But we need to understand too that all of that data is more important to us than ever before. Not only are we generating more data and using it in traditional means for security purposes, but we're starting to use that data for other purposes as well, for business purposes or for operational purposes, or of course for security, but maybe in more of a more proactive stance in the security world. So that data is much more important to us than ever before, and therefore today now we have zero tolerance for things like downtime or data loss that might occur when technology fails, when hardware fails, when software fails, etc. Now, the reason I say this, I tell you this, is that all of this has major implications on how you think about the underlying server and storage infrastructure that you deploy with your physical security systems, in particular your video surveillance systems. So we're going to talk a little bit today really about that concept of infrastructure in the context of video surveillance. But things that we have to think about when we're planning and deploying infrastructure are, we need to think about solutions that can deliver performance, resiliency, and scalability to meet modern demands. Now, I'm going to put that on hold for a second. We'll come back and talk about why that is here in just a few minutes. But let's talk for just a minute here about some of the big trends that are happening. Now, there are dozens of new trends, maybe some of them would call them buzzwords, in video surveillance and physical security today. And many of them are just that, they are buzzwords. However, most of them, when properly planned and properly deployed, can add real value to an end user organization. So these are just a few that you've probably heard of quite a bit in the past year or two. All of these certainly have significant impact on underlying server, storage, and network infrastructure in your physical security deployments. But one of the biggest buzzwords out there today is this concept of IoT, or otherwise known as the Internet of Things. Now, a lot of people ask me, what is IoT? What exactly does that mean? One definition of IoT is that it's a bunch of sensors that are connected to some kind of network, could be the internet or could be another network of some sort, and get connected together and can become accessible anywhere. I would take that one step further. I would say that IoT is actually an organization's ability to transform all of the data being generated by these sensors, thousands or millions of sensors out there, into some form of actionable intelligence. Okay. Now, video surveillance, believe it or not, has been at the forefront of the IoT revolution. In fact, many people would say that video surveillance was actually the original IoT application, even though we didn't necessarily call it IoT back when we started connecting cameras to a network and to the internet. But recent advancements in video technology and new use cases of that technology, combined all that together with declining cost of that technology, are really driving the demand for video to previously unforeseen levels. And that has some real implications on how organizations deploy and manage it. And we're going to talk a little bit more about this here in just a few minutes. In fact, it's really the key subject of this discussion today, but we're starting to see these applications move more and more to the data center and move more and more under IT's control, or at least under their supervisory responsibility. We'll talk about why that is. But before we do that, I want to look at some of the projections right now. And some of these numbers, you may have seen some of these before, but they're really staggering out there. This year in 2019, for the first time in history, we expect over 100 million new IP video surveillance cameras to be deployed. Now, you see how that fits on the chart there on the left-hand side, but what that chart does not tell you is that the average resolution of those cameras is also increasing. So what maybe an average resolution of an IP camera 2 or 3 years ago was VGA or 720p resolution, if you're familiar with those terms. Nowadays, you're talking 3 megapixel, 5 megapixel or higher being a very common resolution of camera being deployed. Now, the higher the resolution camera, the more data that camera generates. Now, you notice on the chart on the right-hand side here, there was an IT analyst firm called Wikibon that this was last year sometime, I believe, they put it, or 2 years ago, sorry, they put out this study that said of all the applications in the world, video surveillance generates almost 2 times more new data on an annual basis than the next closest application. 39 zettabytes, almost 39 zettabytes of new data from video surveillance will be generated in 2019. The next closest application, which is sort of a catch-all term, data processing, kind of a catch-all term for anything that happens in a data center, is about 20 or 21 zettabytes of new data. Now, what's more is the rate of new data generation by video is growing at about 42% per year. So video surveillance is actually the largest big data application in the world by far. And this deluge of new data has significant implications on your underlying infrastructure, your servers, your data storage, your network infrastructure. And I can assure you it's absolutely going to grab the attention of your IT department. Now, we mentioned IoT just a second ago, and I want to put this in context here a little bit for you. I told you that video surveillance was one of the early IoT applications out there, but how does it really fit in the overall world of IoT? Well, what we know is that this year in 2019, about 1 billion new IoT devices will be deployed, and about 10% of those devices, roughly about 100 million or so, will be video surveillance cameras. However, if you take a step forward and you look at this, you'll find that those 10% of devices, those 100 million video surveillance cameras, are responsible for generating 84% of all of the IoT data in the world. So 10% of the devices responsible for 84% of the data. And if you take that even one step further, what you find here is that video surveillance, believe it or not, actually represents about 36% of all the data in the world, not just IoT, but all data in the world. And this was a study recently put out by IDC and Gartner. So video surveillance in the digital world is playing a huge, huge role, and it is leading to our IT departments now becoming much more involved in the planning and deployment of video surveillance systems. Now, a lot of you may recognize and maybe chuckle a little bit at this picture, what you see here, but the image that you see on the left-hand side of the screen is probably one that many of you have seen before. Historically, oftentimes video surveillance cameras were relegated to a closet somewhere with no additional cooling or no ventilation, wires strung all over the place, maybe a DVR or an NVR stuck in that closet with some other equipment in there, and just a real mess, typically managed by the security department or maybe a security systems integrator. Although most integrators, honestly, we know don't really do deployments that look like this, but oftentimes these systems would go down, they'd have failures, things would go bad, and we wouldn't know about those failures until it was too late, until we went back to look at that previously recorded video. So increasingly what's happening because of all this new data, because this data is so much more important to us, is at least the infrastructure part of that is increasingly migrating to the data center and being either owned or at least managed by the IT department. Now, that brings with it some differences. The IT department brings different mindsets. They have different needs when it comes to technology, and they have different expectations in particular of their underlying technology. And we need to understand what those differences are and how we deal with them. Because those differences can oftentimes lead to conflict. And I would guess if you're on this call today, or if you're listening to the recording, you're doing so because you've had some kind of conflict between your security operation and your IT operation. Okay, we see this increasingly all the time. Now, what's interesting here is that both of these groups play for the same team, right? They have the same ultimate goals, which is to keep their organization safe and secure, of course. But some of the underlying expectations can be different, as we mentioned, and can cause this conflict. So let's take a look at what some of these differences are. First of all, the security department. Well, when a security department is thinking about and planning for security technology deployments, there's a couple of things that they tend to look for. They tend to look for, of course, no downtime, no data loss. We want to be ensure that we control costs. But we also look for things like open platforms and interoperable platforms. We look for system reliability. We want our systems to work and to run all the time because we don't want them to get in the way of actually doing our jobs. We look for very simple management of those systems. We don't want to have a PhD in IT in order to manage our systems on a day in, day out basis. And of course, what we're primarily interested in physical security. So all this really boils down to the security department's primary mission is to manage risk within their organization. Now, on the other side of the house, the IT world, they share some of the same goals. Of course, they want to prevent downtime and data loss, and they want to control costs. In fact, things like downtime and data loss in the IT world are oftentimes of utmost importance. That can be the thing that really keeps them awake at nighttime. But then we start to see some of the needs change and vary a little bit from what the security department works. As opposed to open platforms, they may look for something for familiar vendors and technologies that they've worked with before. As opposed to reliability, they may be more concerned about things like workload consolidation. We'll talk a little bit about what that means here in just a few minutes. Integration into their existing management systems and tools and technologies that they already have, because this is all they do on a day in, day out basis is manage things. And then, of course, when you talk about security to an IT person, the first thing that comes to their mind is information or data security. So ultimately, what they spend the majority of their time doing on a day in, day out basis is trying to manage complexity for their organization and complexity for themselves in their own jobs. Remember, an IT department is responsible not only for the physical security systems, but oftentimes for all of the different technology that's running inside of an organization. So these varying needs and expectations can lead to conflict, as we talked about. And conflict with IT is a recipe for disaster and for bad things happening within your organization. So how do we resolve this? Well, what I would tell you, and what we're going to talk about here, is the way to resolve this is for you to play the role of educator within your organization. Now, I want to start out here for just a second helping educate you. The first thing that you have to do when we talk about educating is you have to educate yourself. You have to understand some of these unique, very complex and sophisticated sounding terms that are out there in the IT world. Now, I'm giving you this slide, and I know we're going to make this available to you afterwards, really as a reference tool. My goal is not to go through every single word of this here, but to let you know that some of these big, complex sounding terms like software-defined everything and virtualization and hyperconverged and cloud, all of these things sound big and complex and expensive and everything else, but I want you to really not be too afraid of them. Okay, like every industry and every function, IT tends to put a lot of complex sounding terminology around things, maybe when it's not necessarily needed. Some people might say it's for job security, but a couple of these that I want to point out here, things like software defined. What software defined actually means is you replace big, expensive proprietary hardware with software. Okay, because it's as simple as that. Big, expensive hardware, we're not going to do that same kind of thing, and with software running on low-cost commodity hardware. You probably know what virtualization is. We talked about infrastructure a little bit. In a few minutes, we're going to talk about some different types of infrastructure options that are out there, converged and hyper-converged infrastructure. I just don't want you to be overwhelmed by the terminology that's out there, but it is very important for you to understand this terminology so that when you're going in and you're having discussions with and negotiating with your IT department, you understand the language that they're speaking. Now, most people on this call, I'm sure, are likely to have come from the security world, the security industry. So I want to talk a little bit about how important it is for you to help educate your IT counterparts to ensure proper collaboration and so that everyone ultimately achieves all of our goals. There's a couple of things that I'm going to want you to educate IT about, and I'm going to give you some of the tools and some of the knowledge that you need to go out and do this education. First of all, IT needs to understand that video surveillance is actually different than almost any other application that they're familiar with in their data center. And as a result of that, traditional infrastructure solutions that they are familiar with and that they're used to deploying are really suboptimal. They don't work very well for video surveillance. And we'll talk about why that is here in just a minute. But we need to understand, and they need to understand, that some of the latest IT technology that's emerging today can be leveraged in a way to help both organizations achieve both of their goals, which is to reduce risk and to reduce cost and complexity. And ultimately, we're going to be here to help IT understand that we can help make their lives easier. So let's talk about the first one, that video is different. Why is video different, and why should IT care about this? I told you at the very beginning, there's three things you need to think about when planning and deploying infrastructure for video surveillance. You need to think about performance, resiliency, and scalability. Let's talk about those three things and why that is. First of all, performance. Performance really matters. Now, when I say performance, what I mean here is I mean a system's ability to take in or to ingest video data without any kind of loss. Okay, loss means data loss, which can lead to frame loss, which can lead to some very bad things. Now, your IT department needs to understand that video surveillance does not look like a common IT application. Most IT applications that run in a data center are, this is a rule of thumb, but 20% of the time, those applications are writing data to a disk, and 80% of the time, they're reading data from a disk. And as a result, most infrastructure solutions are optimized for that 20% write, 80% read kind of ratio. Video surveillance is the exact opposite of that. Video surveillance is more like 95 or even 99% of the time, we're writing data to a disk. And what's more is video is a highly variable application, and it's prone to these data spikes. Right, data coming out of a camera can spike up very quickly when the activity within the scene of that camera increases. Maybe a classroom is just let out, or an alarm goes off, or something happens. Suddenly, the amount of data generated by that camera spikes. Well, when those kind of spikes occur in a write-intensive application like video, it can quickly overwhelm a storage system's ability to take in that video, take in that data. And when when we do overwhelm a system like that, it leads to data loss, which in the video world is called frame loss, which is a really bad thing for video. Frame loss leads to one of two things. You either degrade the quality of the image. That's a big deal when you talk about investing money in high resolution, high definition video surveillance technology, and suddenly you get an image that looks like a very old low resolution camera. Or it could potentially lead to the loss of entire segments of video. So your infrastructure needs to be able to perform in a way to take in all that video without any kind of loss. Second is resilience. And when I say resilience, what I mean is protecting your systems against downtime and data loss that result from hardware failures or software failures or some kind of major failures from happening out there. Now, believe it or not, there was a study done by, I think it was Google a couple of years ago, that said that hardware used in video surveillance applications is 3 times more likely to fail than that same hardware used in non-video applications. And that really goes back to the first point about how much data we are constantly writing to a disk 24 hours a day, 7 days a week, 365 days a year. Now, our IT departments will tell us, we've got all kinds of great technologies in our data center that can help protect our systems against downtime and data loss to ensure we're always online, we're always recording, we're always have access to live video and previously recorded video. What I'll tell you is that most of those technologies that they are familiar with can be either prohibitively expensive when used in video surveillance, or in many cases, they just don't work. You can't take snapshots of video systems. It just doesn't work. You really can't effectively back up video data. Now you can, but there's some real challenges when it comes to restoring it. Solutions like replication and cloud can be prohibitively expensive in large scale or storage intensive applications like video. And even RAID technology, which was developed back in the 1970s, is very inefficient for a video surveillance application. So we need to think about other ways of protecting our systems against downtime and data loss that result from hardware failures, understanding that hardware is actually more likely to fail in video surveillance. And the last one is scalability. Now, probably the worst kept secret in the world of video surveillance is that video systems never get smaller over time, and they almost always get bigger. And now, there can be lots of different reasons that they get bigger. It could be they're adding new cameras, or they're upgrading their technology to the latest technology. It could be that maybe they didn't properly plan or deploy their technology in the first place. There's many different, maybe they've increased their retention time. There's many different reasons that video surveillance systems get bigger over time. But there's a common misperception out there that as my video system gets bigger, I simply have to scale storage capacity to keep up. And that's not, well, that's true. It's not the entire picture. As your video system gets larger, you need to be able to scale storage, compute, and bandwidth capacity. And you typically need to do so linearly, meaning together. And you always need to do so without disrupting the operation of your existing system. So 3 very important things to think about: performance, resilience, and scalability as you're planning your technology and system deployments. So let's take a look at some of the options that you have for video surveillance infrastructure today. I really want to look at compare and contrast 2 primary architectures out there. The first one is one that I'm sure you're very familiar with, the NVR, Network Video Recorder. This is the most prevalent type of infrastructure technology available today. It's the one that's most deployed. But it really has some pretty significant drawbacks. Now, believe it or not, an NVR was designed originally to look, act, and feel like an older analog VCR or DVR. Our industry sort of grew up around this concept of you have a camera, you plug it into a box, you push record, and everything just works. Well, as the underlying camera technology changed from analog to digital, the underlying infrastructure technology changed as well. But we came up with this concept of an NVR because we wanted to replicate that experience of having a box, plugging a camera in, and pushing record. An NVR is nothing more than a standard off-the-shelf server combined together with some video management software and sold as an appliance. And NVRs can work very well for smaller systems. So think about systems of less than 60 or 70, maybe up to 100 cameras or so, depending on what kind of cameras you're talking about. But as your systems get larger and you start talking about dozens or hundreds or even thousands of cameras, NVR architecture can have some real challenges and drawbacks to them. The first and foremost is there's a problem that we call stranded resources. And what I mean by that is a camera only has access to the resources inside of the NVR that it's physically connected to. Well, that can lead to some challenges around unreliable performance and, more importantly, unreliable retention times. The process of calculating and determining how much storage and how much bandwidth and compute you're actually going to need can sometimes be somewhat challenging. And so in order to meet retention times in this big NVR kind of environment, you actually have to over provision typically and kind of buy for the worst case. Secondly, you make yourself vulnerable in an NVR scenario to single points of failure and very poor levels of data protection. So if an NVR fails, there are some ways to get around that through software, but you really have a lot of limitations when it comes to protecting and ensuring you can access all of your data at all times, ensuring your systems are always online and always operational when those failures occur. And then lastly, as NVR-based systems get larger, an NVR itself cannot be scaled larger. You can't make an NVR any bigger than it is. So you have to simply add more NVRs into the system. You have to just basically stack them up on top of each other. Now, the video management software does a pretty good job of making those stacks of NVRs look like a single system, but the reality is that they're not. There are a whole bunch of systems standing next to each other, and they all have to be managed and administered individually for themselves. So if you have 10 NVRs in your system, you have 10 individual systems that have to be managed, that have to be patched, that have to be upgraded, that have to be given regular maintenance and everything else. So it can be a real challenge to manage NVRs up at scale. Now, on the other end of the spectrum is enterprise infrastructure architecture. The IT world would come back and say, we stopped using that NVR-like architecture in our data centers years ago because of all these problems that I just explained to you. And they moved on to a much more modern architecture where you have separate servers, application servers. They could be physical or virtual, but application servers, and they're all accessing some shared storage medium like a SAN or a NAS that you may have heard of. And this kind of architecture can solve a lot of the challenges that NVR or direct attached storage systems like NVRs pose. It eliminates that stranded island of resources that, like I told you about. It can potentially eliminate the single points of failure. However, we need to understand that this kind of architecture was designed and optimized for that general purpose IT application, which I told you before was 20% of the time writing data to a disk and 80% of the time reading it from a disk. And as a result of that, this type of architecture tends to perform very poorly for a video surveillance kind of application. And that leads to those frame loss, which leads to the image quality degradation and potentially loss of entire segments of video. In addition to that, this enterprise architecture is typically very expensive. It's built on proprietary single-purpose hardware and oftentimes requires a person or teams of people, highly trained, in some cases highly paid people that are dedicated to managing that infrastructure on a day in, day out basis. Their only job is to manage server and storage infrastructure, which we know for most security departments and organizations is really not a resource that we have access to. So we have two types of infrastructure architectures out there, and neither of them are really well optimized for a video surveillance kind of deployments. Now, before I tell you how you can go about solving some of these problems, I want to shift gears for just a second and talk about some of the big trends, one or two particular trends happening in the IT world. And I tell this to you for a reason, because it's ultimately going to come back and play a role for you as you're planning your physical security deployments as well. Now, like most functions, IT organizations a few years ago started looking for ways to reduce cost and complexity. Their businesses or whatever organization they were in came to them and said, we need you to reduce costs. We need you to get more streamlined. We need you to figure out how to do what you do in a more cost-effective manner. So they started taking a hard look at their data centers. And what they actually found was that these data centers were actually massive cost centers, as you can imagine. So some of these big major innovators, technology innovators, like a few of them that you see on the screen here right now, came up with ways to significantly reduce the cost and complexity of their data center. They did that by eliminating all of that big proprietary hardware. If you walk into a data center, you see racks and racks of equipment and blinking lights and fans and all kinds of stuff. They moved to eliminate a big chunk of that proprietary hardware and significantly reduce the cost and complexity of it by building their own infrastructure on low-cost commodity hardware with software that replicated the functionality of all that big, expensive proprietary hardware. Well, that's great. That's companies like Amazon, Facebook, and Google, between them, probably have 100,000 people working in their IT departments, right? So they can afford to do things like that. But most organizations don't have the resource and really even the ability to do that, to make that kind of switch on their own. And so that for everyone else that's not Amazon, Facebook, and Google, a new category of technology has emerged to deliver that same kind of software-defined solutions, or the benefits and the features of software-defined solutions like an Amazon, Facebook, and Google has. And that's called Hyperconverged Infrastructure, or HCI. Now, HCI, just as a frame of reference for you here, HCI is significantly transforming what's happening in the data center. It's really disrupting and changing data center technology. It may not be something that you and I see on a day in, day out basis, but it's significant changes are happening behind the scene. And what you see is traditional infrastructure on the left-hand side, which is big, it's complex, it's got all kinds of different part pieces and technology, it's super expensive, it's very cumbersome and very costly to administer, is really moving towards this scenario that you see on the right-hand side of the screen, which is much simpler, much lower cost, much easier to deploy, much easier to scale, much easier to change over time. And so hyper-converged infrastructure is really driving significant change in our organization's data centers, whether we know it or not. However, early iterations of hyper-converged infrastructure tended to be built, defined, optimized for very specific applications, very specific use cases, very specific workloads, et cetera. And they really weren't ready for prime time when it came to running an entire data center or an entire ecosystem of technologies together. But recent advancements in hyper-converged infrastructure really have matured the technology pretty significantly, and it's really now primed to take over larger portions of the data center or entire ecosystems of technology together, and ultimately help organizations reduce costs, reduce complexity, and improve the performance of those systems. So I'm telling you this for a reason, because here at Pivot 3, not just at Pivot 3, but there's an emerging category now of technology out there, which is hyper-converged infrastructure that's been purpose-built or optimized specifically for video surveillance and physical security applications and deployments. So the concept of hyper-converged infrastructure in physical security is really about taking the best of both worlds of the NVR and the enterprise storage architecture that I showed you before, and combining it together in a way that makes the most sense for a physical security deployment. Now, I don't want to get too technical here today, but I want to briefly tell you about how this works and what some of the benefits of this kind of architecture is. If you look at the diagram on the left-hand side of your screen here, Hyperconverged infrastructure starts with standard off-the-shelf server hardware. In many cases, the same hardware that you would that are used by NVRs. Those servers are deployed together in clusters or in groups, and then they have a couple of pieces of software on them that really turn those groups of servers into high-performing enterprise-class infrastructure. The first piece of software is represented by the little gray boxes you see on your screen there. That's server virtualization technology. Pretty standard in the data center, but still an emerging concept in the physical security world. Then that effectively gives you the ability to consolidate applications that have historically been deployed on multiple different servers, multiple different machines, physical machines, consolidate them together onto one common infrastructure. So that could be your video management software, could be your electronic access control software, could be any kind of application. Video analytics or artificial intelligence, PSIM, building management, visitor management. There's any number of different types of applications that can be consolidated together and run on one common infrastructure. And then you have specialized hyperconverged software. In the case of Pivot 3, our software is called Acuity, and that does a couple of things for you. First of all, the hyperconverged software will actually extract all of the storage resources in each one of these physical boxes that you see. So all of the hard drives, the solid state drives, even the bandwidth, network bandwidth, and aggregate all of them together into something called a virtual SAN. And that virtual SAN, now the entirety of that virtual SAN becomes fully accessible by every single virtual machine. And there, in the case of video surveillance, therefore, every single camera, regardless of which physical machine that camera or that application is associated with. So we are making groups of hardware, NVR hardware, look, act, and feel like enterprise class shared storage infrastructure. Now, in addition, the second thing that hyperconverged software does for you is it actually serves as the storage controller inside of these. And what that means is it manages how data is moved from the application down to the physical hardware layer. And that's what gives it the ability to be optimized specifically for a video surveillance kind of workload. And then the third thing it does is it adds some additional capabilities and features and functionality to your infrastructure that standard bare metal servers just can't do. So if you notice on the right-hand side of the screen, the typical benefits that you'll see from deploying hyper-converged infrastructure for video surveillance and physical security applications is the highest levels of resiliency to effectively eliminate downtime and data loss that might occur because of hardware failures. Ensuring that even when major hardware failures occur, your systems are always online, they're always operational, you always are recording, you always have access to live video, and you always have access to any previously recorded video, even when major hardware failures occur. Secondly is hyperconverged can be optimized in such a way that can allow you to achieve the highest levels of performance for a video surveillance application and eliminate those frame drops that I told you before are so bad and sustain that level of performance again, even when major hardware failures occur, which is a very common problem with NVRs and other kinds of technologies out there, that when hardware failures occur, they go into what's called a degraded mode, and suddenly they can handle a lot less video than before. Thirdly, you want to ensure that, hyperconverged will allow you to be highly scalable. You can start small, and then as your needs change over time, by simply adding a node or adding a box into the cluster, you scale storage, compute, and bandwidth for the entire cluster. And you do so in a very simple 15-minute process that's non-disruptive to your existing systems. Scaling these systems is extremely simple over time. It allows you to consolidate workloads or consolidate applications, like I told you before, which effectively means that you can eliminate massive amounts of hardware and you can administer all of this together from one common interface tool, from one single pane of glass, as the IT world would call it. And the great thing is you get all of this really enterprise class capability without the cost and complexity typically associated with enterprise class infrastructure. Now, I tell you all of this really for a reason, and that is that your IT departments are increasingly moving to this kind of technology in their data centers, and they're expecting this kind of technology even in your physical security deployments. Now, hyperconverged technology, not just Pivot 3, but hyperconverged technology in general, by its nature, by its definition, is open platform. There is no engineering integration that's required to ensure hyperconverged technology works with the application running on it. Virtually every video management platform, most of the access control platforms, increasingly most of the video analytics platforms, and all the other types of applications that are out there natively support hyperconverged infrastructure. As long as they run on an x86 processor in a virtualized environment, which virtually all of them do, then they will run in a hyperconverged environment. Now, many of you may ask, well, all of this stuff sounds great. Resiliency, performance, consolidation, scalability, simplified management. What does this actually mean? How do I actually tie this back to business impacts? And the great thing about this is that you can directly tie the benefits of this kind of technology back to business impacts. Better resiliency, meaning you prevent downtime and data loss, means that you reduce risk. You reduce risk that may be introduced by your technology itself. Higher performance, eliminating frame drops, means you maximize the effectiveness of your system. An ineffective video surveillance system is not worth the money that you invested in. Workload consolidation and scalability ensures that you can reduce costs, reduce the costs of acquiring and deploying this technology. And of course, simplified management means you can not only reduce the cost of managing these systems long term, but you really meet the needs and expectations of your IT department. Okay, so if I were to summarize this, what are some best practices when it comes to working with your IT department? Let's talk about some do's and some don'ts here. Let's bring this all back together. What I want you to do, be sure that you educate yourself and educate your IT counterparts. Engage IT early in the process of planning your physical security deployments. Don't wait until you're about to go out for bid. When you're about to go out for bid, if you wait till then and to engage your IT counterparts, it's too late. You've waited too long. Look for IT-friendly solutions. Look for technologies that meet the expectations of your IT department, that speak the same language that your IT department speaks, and that really does the things that they want them to do. And become a trusted advisor. Help them understand why, not only that physical security technology is different, but why it's different and why that matters. What are the implications back to your business or your organization? Do not skip this. Don't skip this step. Don't not go and talk to your IT department because you're concerned about them, or because you're afraid of them, or because you're intimidated, or anything like that. Don't do that. Do not be intimidated by IT. They are people just like all of us. No, their language may be a little bit different, and they may be more technically competent than some of us in some of these cases, but understand that they're ultimately have the same goals for the organization that you do. And don't try to come back and quote unquote sell your organization on NVR technology if you are have a larger scale video surveillance deployment, and one in which that I would call mission critical, meaning you have no tolerance for downtime and data loss, because that can really put you in a bad position and can hurt your organization ultimately long term. Okay, in the interest of time here, I'm going to go quickly through one or two real world examples here of how this technology can be deployed. The first one I'll point out, University of Central Florida. It's the second largest university in the country by enrollment. They had a situation a few years ago where they actually had an active shooter on campus. And it was an interesting scenario because their public safety department actually had access to video surveillance cameras all around the campus from a centralized place. However, when that active shooter incident occurred, it took them about 4 hours to access that video, which anyone in the security world knows that that's about 3 hours and 59 minutes too long. Now, luckily, in this case, the shooter's gun actually jammed, and he didn't cause any harm to anyone other than himself. So nothing bad did occur, but we all know what could have occurred. So after this happened, the security department or the public safety department went back to their IT counterparts, and they formed a collaborative environment with IT and a newly formed emergency management department. They actually did a study of what kind of technology they had deployed around their campus, and what they found was pretty eye-opening to them. They had 58 separate standalone security systems, video surveillance systems, about 12,000 access control points, and all number of different vendors there on campus. Just an unbelievably disparate environment. So they came together with IT and emergency management, and they designed a system that would allow them to consolidate all that technology together, significantly reduce their costs, but more importantly, improve their resiliency and ensure that first responders had access to their video surveillance and their related security systems in the field when they needed them at the time that they needed them. Really ultimately helped them create a much safer campus. On the opposite end of the spectrum, FedEx Ground is an interesting case. This is one where highly distributed environment. They have about 1,000 facilities across the US. Each one of those facilities had about 30 to 50 cameras in it, so relatively small systems. But the challenge that they had was they had no IT resource at each one of their sites, but they needed to be able to deploy and upgrade and change and manage all their systems from one place in a centralized location. So they turned to hyperconverged infrastructure to help them deploy remotely and significantly reduce the amount of time it took them to deploy and manage all those systems. It took their deployment time down from 2 to 3 days to something like 2 to 3 hours. So you're talking about significant cost reduction and much greater efficiency when it came to managing those systems. And the last one I'll tell you about here, and then I'll open it up for some questions, is Iron Mountain. Iron Mountain you may be familiar with. They've been in the records retention business for a long, long time. A few years ago, they actually started a new part of their business called the Iron Cloud, which is just what it sounds like. It's a cloud data center that they use for their customers to host all their applications and their data. A few years ago, they created an extension of that called the Iron Cloud for Video, which was effectively an archive depository for video surveillance where customers could store their video for long-term purposes in highly secure, highly resilient data centers built into the side of mountains, literally. Well, this is a situation where Iron Mountain was actually handling their customers' data. So things like uptime and data protection, these are of utmost importance to them. And of course, scalability over time, as more and more organizations signed up for this, need to be able to scale over time. So they turned to hyperconverged infrastructure to help them offer a new service actually to their customers, to their market, that gave them the level of resiliency and performance that they needed, but also gave them the scalability that they needed to deploy this kind of solution over time. Okay, sorry I ran through those real world situations kind of quickly there. I'm going to turn it, I think, back over to Ron now and see if we have any questions here in the last few minutes that we have.
All right, thanks a lot, Brandon. That was a great presentation. Let's get to the questions. Who typically provides hardware for large video deployments, IT or the security integrator?
Well, I would say for the most part, I'd say it's the security systems integrator. But I'll tell you that is changing. It used to be that systems integrators would provide turnkey solutions end to end, right? Everything from the camera all the way back to the infrastructure. Increasingly now, since IT is getting involved, we're seeing that they sometimes they decide to buy that infrastructure from their IT providers. So the integrator is missing out on that. I think that's actually happening more and more. It's happening because systems integrators maybe aren't providing the kind of solutions that IT departments expect. So it's a good question. It ties back to this discussion we've just had. Understand the kind of technology that IT departments are interested in, so to help you protect that part of your business to ensure that you can deliver those kind of solutions as well.
Okay, great. All right, what other applications can a client consolidate by virtualizing their video system?
Well, we talked about a few of them. I think the most logical, the answer to that is any kind of application, but the most logical are the applications that are directly integrated to video. So access control, visitor management, building management, et cetera. But we're actually starting to see some of our customers that are now maybe deploying hyperconverged for video surveillance and then putting all kinds of other applications, non-security applications, onto the same infrastructure. So we might see email servers or finance systems or web server, whatever it happens to be, gets consolidated together because you have a highly performant, highly resilient infrastructure there. You might as well use it for other applications. So the answer to that is really any kind of application, but the caution I'll give is to ensure that you work with your solution provider to properly design and size those systems to handle the application that you're putting on it.
Okay. Speaking of virtualization, most VMS companies recommend that their servers that the servers should not be virtualized. How do you overcome these limitations?
Okay, so that's a common piece of feedback that we get. This is, I think, a result of the security industry technologically lagging behind the IT world. Many VMSs have recommended against virtualization. You're correct. And the reason for that is that typically when you virtualize an application, there's a process that happens. The data actually gets handed off from the application to a piece of software called the hypervisor, and the hypervisor manages the process of writing that data to disk. That handoff process can introduce anywhere from a 20 to 30 or even 40% performance reduction in your write process. And for most, IT applications, that's not a big deal, but for video surveillance, it's a very big deal. So what hyperconverged allows you to do is it allows you to bypass that hypervisor and write that data directly to disk. Now, what that means is you can virtualize your video management software without incurring that performance reduction that you would typically see in a virtual environment. So and most VMSs actually support it. They don't always recommend it because it's sort of a legacy mindset out there.
All right, great. Well, it looks like we are at the 2-hour mark now, so we'll bring things to a close. Do you have any closing remarks, Brendan?
No, I think that's it. There's some good questions. So thank you everyone for joining today. We've got some information up here on the screen. If you're interested in getting in contact with us, please feel free to reach out.
All right, thanks a lot, Brendan, and thank you everybody for attending the webinar today. As I mentioned, we will send out an email containing a link to the recording of the webinar as well as a PDF of the presentation. So thanks again. Thank you, Brendan, and have a great day.